So with that, I'm going to turn this over to Chris Cain and Chad Hogg for Unity for Game Development. Chris Cain, as you probably heard us talking just a few moments ago, he is a new assistant professor of comp sci at Millersville University. Chris's research interests include designing games for classroom motivation, and he will be teaching game programming in the spring semester of 2021. Chad Hogg is a Lancaster County native, assistant professor of computer science, also at Millersville University. He has been interested in game design development since childhood. Taught a course on the topic for the first time in fall 2019. So we're thrilled to have Chris and Chad here from MU to tell us all about Unity for game development. So take it away, gentlemen. I'll be in the background if you need anything moderating, and we're looking forward to your talk.
All right, thank you.
Thank you.
Charlie said that I've been interested in game design and development since childhood, which maybe is overstating the thing. I've be interested in playing games since childhood, and really became a computer science major because I wanted to learn how they worked and build my own, but then never really got into it, never had any time to spend on game development. And as he said, a year and a half ago, I was asked, could you please develop a new course in game development for us? And having absolutely zero experience in it whatsoever, I did a mad scramble through trying to find books that I could read, looking at what seemed to be popular. And what I came to a conclusion was that at least the start would be to use the Unity engine. So if you were watching the talk that just ended on game jams, you saw that there are a great many of other options. And I can't tell you that Unity is necessarily the best one. It's simply the one that I chose to learn for the purpose of teaching that course. And as you also heard in Charlie's talk, that course that I developed a year and a half ago, Chris is going to be teaching next semester. So that's why we are doing this together. It's sort of my way of passing on the knowledge that I gained through teaching the course to him. Rather than take a very broad approach like that game jam talk was, we're going to actually build a very simple game piece by piece, so that we can show you all the different kinds of things that you might want to use when building a game, and get a sense of what's available and how it all works. The kind of game we're going to build is a 2D platformer, because 2D is generally much easier than 3D, more straightforward. You can easily see what's going on. And a platformer is a game type that I'm guessing all of us are familiar with, have experienced at some point. So Unity is a system of libraries that you can call in code. It's also an editor program that allows you to do an awful lot without actually ever even touching any code. We're looking at the Unity editor on our screen right now. It's divided up into several different sections. Over here, we have a window called the hierarchy window, where we can see all of the game objects that exist in our game. A game object is simply a thing that has a position in the world, and perhaps lots of other things associated with it. Each object can have a variety of components of both types that are built into the system, types that you create yourself. Here, we can actually see the objects in the world. Currently, we can't really see anything except a camera. That's by design. We'll be adding things later. Over here is a window called the inspector. It's actually tabbed. We'll see there will be several things there over time. But the main use of it is the inspector, where you can look at an object in your world, add components, remove components, and configure components from it. So, for example, if we were to select the main camera, we would see in the inspector that it has a transform component. This is a required element that every game object automatically has. It basically says where the object exists, its size, and its orientation in the world. This also has two additional components, a camera component and an audio listener component. The camera component is what allows us to say the world is infinitely large, but we are looking at a of it right now, and we can change what part we're looking at by changing the position. The listener is what allows us to, if we had sound effects, which we won't be doing today, determine how far the source of the sound is from the listener of the sound, as we might modify the volume in some way based on that, or the panning of it right or left. The other object that currently exists is called a grid with a tile map. We'll be talking about that a little bit later. We created that in advance because we wanted to not have to show you some of the fiddly, take a bunch of times to build phases of this. And then down here, finally, there's one more window where you can see all the assets that are available for you to use in your game. We've pre-built a bunch of assets that we'll be using. So much of what you might do in here is creating stuff using built-in things that Unity already has, adding components that they already have, and configuring them. But eventually, you're probably going to want something to do something that you have designed. And this is where you actually write your own code in scripts that are built in C#. So most of the stuff that we have pre-built is scripts that when we get to them, we'll go through and explain what they're doing. To start out, we're probably going to need a player object, something that's going to represent us as we move about on this platformer game. You heard in the previous talk about game engines that images in a game are called sprites. So we're going to need a sprite that will represent our player. If we had some artistic skill, we might create an image to use as our sprite in some external image editor, or we might go find one that we could use. But because I don't want to do either of those things, I'm just going to create an extremely basic thing that can represent our player, and it will just be a square. I will do that by creating, in our assets collection here, one of a variety of different options of things that are available. I'd like to create a sprite, which is a submenu here, and specifically a square sprite, and give it some kind of name, like character sprite. Then I'm going to create something in the world. I'm actually going to create an empty object that will have nothing except the required components, which is a transform saying where it is and how it's oriented, and then we'll add components as we need them. So this empty object, I'm going to rename to be called our player. And we can see over here the only component it has right now is a position. I'm going to change that position to put it at exactly 0, 0, 0. The center of the world. And then I'm going to add a component to it. I would like to be able to see something that represents our player. Specifically, I'd like to be able to see this sprite that we've created. So I'm going to use a component called a sprite renderer. A sprite renderer allows me to specify a sprite that I want to appear at the location in the world where my object is. And I can specify what sprite I want to use by dragging the sprite I created into here. So I now have a little white square in the center of my world. That is my player. But perhaps I don't want my player to be white. Perhaps I want it to be some other color. I can accomplish that by double-clicking this and choosing some other color. Let's make our player, what have we been doing, green? Yeah. All right, so now we can play our game and see that it will be incredibly uninteresting. If I press this play button up here, we'll get the game to get compiled and run. And here's our game. We have my player. He's just sitting there among a background of blue that comes from our camera, and nothing happens here. I can't interact in any way. Our player is just sitting there. So we don't have a very interesting game yet, but we're going to get there. The next thing that might be helpful is if our player responded in some way to physics. In particular, in a platformer game, if your player doesn't have anything underneath them, they should be falling toward the ground, following the rules of gravity. So we'd like to make our player follow those rules. We want to incorporate the physics engine that is built into Unity and apply it to our object. To accomplish that, we're going to add another type of component. This type of component is called a rigid body. Because we're working in 2D, we're always going to grab the 2D versions of these things. There are also 3D versions. So we want a rigid body 2D. It's got a bunch of things that we can configure here, but for now, at least, we're not going to. We're just going to play our game and see if anything's different. That's better. Our player is now controlled by gravity, and if there's nothing stopping him from falling, he falls. Unfortunately, for now, he falls forever and ever and ever, but we'll fix that later. Anything I've forgotten to discuss yet, Chris?
Did we want to make a quick reference to licensing?
I did. So this is the Central Pennsylvania Open Source Conference. The Unity engine, the thing that we are currently working in to build our game, is not open source. It is closed source. However, many of the components that we're adding are open source, and anybody can create components and make them open source themselves and share them with the community to use. In addition to being closed source, it is not free software. It is proprietary software. However, it is free as in beer for most people. It has extremely generous licensing. If you want to use Unity for educational purposes, for hobbying purposes, or even for commercial purposes, you can get a license that gives you the right to do so for free, as long as you do not make more than $500,000 off of the things that you create in Unity. And if you do, you'll easily be able to afford the licenses that you have to pay for. All right, so our player falls down. It would be helpful for them to have something to fall onto, and indeed to move around, jump from one to the others, etc. So we need to create some platforms. In order to do so, we need something to make our platforms out of. This is also something that you might have heard already in the talk previously about game engines. We're going to use a sprite sheet, which contains a whole bunch of little images connected in a larger picture. That is this. If we open up this drawer, we can see all the individual images within this sprite sheet. We need to convert that sprite sheet into a series of tiles, and I have pre-done that before we started the lecture or the presentation, and in fact, even started painting this grid with them. This grid allows me to put tile maps on it, and tile maps allow me to paint with tiles, which are just images taken from a sprite sheet. So we've been using the inspector here. The other tab here is a tile palette, where I can grab tiles and paint them onto my tile map. So let's see if I can manage to do that and make a little platform here underneath our player. And perhaps make an additional platform that the player could jump to in the future. Now we can play our game, and we should be able to see the platforms there. Unfortunately, as you noticed, our player still falls straight through our platforms. So they're not really serving their purpose. They're just being displayed there, but they're not actually doing anything. They don't interact with physics in any way. So it would also be nice if when our player was on a platform, they would not fall through it, but instead stop. In order to accomplish this, we need another kind of component, another one that is built into Unity, because virtually all types of games need this. We need some way to detect collisions between objects. To do so, we're going to add a collider component to both our platforms and our player. There are a variety of different types of colliders, and we want to choose the type that matches the shape of the object that we're dealing with. So our tile map is going to have a component added to it called a tile map collider. 2D, of course, and we'll leave all of its options at their defaults. We're also going to add to our player a type of collider. In this case, it'll be a box collider because our player is square-shaped. If it was different shaped, we could choose some other kind of collider. And without having to configure those in any way, we should be able to see that now our player, when it hits the platform, stops. Because by default, if we are detecting collisions when two things collide, they can't move through each other. So our player is sitting there on the platform, and he is stuck because we currently have no input, no way to control our character at all. It would be nice if we did so, and to get to that point, we're finally going to be writing some code, doing something that feels like we are developers doing some computer science. So I'll let Chris tell you about how that's going to work.
Hello, everyone. So the first thing we think about when we're looking at this and saying, all right, what do we need to do at this point? It'd be nice if we could get some kind of input and use that to control the player character. So that is what we will do first. We want to add a script to the player that will control the player's movement. So we will go to this step. We will select the player, and we want to now add to the player a component that is this script that we have already written here. And I will first attach it, and then I will open it and describe what it does. So you just drag and drop over the add component. Enough, we have now attached this player movement script. But let's quickly open it up and take a deeper look into what it does.
Is that font size working, or do we need to make it larger?
If you could increase it, that would be helpful.
Let's see, here's a faster way to do this.
Yeah.
How about now?
That's for my over 40 eyes. That's looking better. Thank you.
All right.
Excellent. So here we have a class that describes the behavior of this. We have a couple fields, the private rigid body and a public horizontal force that will be applied when we press the appropriate button. Scripts in Unity use C#, and there are two methods that you get by default when you make a new script. You get start and update. We have turned update into fixed update, and I will describe what that does in a second. Start is a method that runs when you begin the game. So we, of course, want to get our rigid body component and store that as a variable that we can manipulate. Fixed update is a slightly different version of update. Update would run once per frame. However, we want to run a constant number of times just in case the number of frames vary. We don't necessarily want that to affect our movement. So we are going to call fixed update. And when we get the appropriate input for horizontal movement that has been pre-mapped in Unity to be, for the case of this demo, it is the right arrow key. We will transform in the right direction by the amount that we press either right or left. We will scale that by horizontal force, which we have determined to be 7.0. This is just a number that we tested, and it works for the scope of our project. Are there any questions about what is going on in this script? Okay.
Not seeing any.
So I dragged and dropped this over the player. It has been applied. We can see that the text is probably a bit too small to see, but here is an editable field now for horizontal force. We can actually change this here, but the public field from our script is now an editable field in the UI. We can now play the game and see what happens. And here's where you hope there are no bugs, because this occasionally does get stuck, and it looks like, sure enough, I can move left and right as I press and hold the left and right arrow keys. Unfortunately, there are a couple of unintended consequences. As I move off the ledge, you'll see that, in fact, our player character actually rotates. And this can be a bit of a problem. If we actually rotate our character, the force that we see may be applied in directions that we don't intend. When we press the left and right arrow key, we want the object to move left and right. And if we find ourselves having rotated, the force that gets applied is based on the local object. So we may end up not quite moving left and right. So we want to do something about that, which we can do if we find ourselves back in the inspector here. We can freeze Z rotation. It's just this checkbox right here. And now when we play, we note that when we move off of our platform, we no longer rotate, and this means that any force that is applied will continuously be applied left or right. All right. Success. we want to move onwards. The next thing that we might reasonably want to do in a platform game, it's not much of a platform game if we can't jump. So let's talk about how we might implement jumping. For this, we're going to update our player movement script. So rather than write this, we've pre-written it. So you can delete a script off of an object by right-clicking and removing the component. I will remove this component and I will attach the new player movement script. I will open up this player movement script and let's see what has changed. In addition to a horizontal force, we have a vertical force. This is useful for when we press the appropriate button, in this case the pre-mapped Unity button for jump, which is the space bar. We will transform in the up direction. Our player, when we press the jump key, scaled by the vertical force that we've defined to be 18. Again, this is just a tested value that displays something like we might expect. So let's see what happens when we play the game. In addition to being able to continue to move left and right, we can now press our key and jump. Except what's going on here? This doesn't quite follow the rules that we might anticipate with jumping. We more so have a rocket pack than we have legs, which may be fun for some game, but we want to build a platformer, and we want something that will look like an actual jump. So let's take a look at that. I will again repeat the prior step of moving to our player object, removing the old script, and we will attach our new script. Okay, let's open up this script and see what changes we've made. Note that we have immensely scaled this vertical force because if we think about how jumping is going to work, we want to apply an immense amount of pressure while we are on the ground, and then we want the ability to do that to stop until we are back on the ground. We call this the concept of grounding. So the start method looks the same, but we have a couple new methods here. We have on collision enter 2D, on collision stay 2D, and on collision exit 2D. These will identify when we collide and or when we are attached to the ground. So let's start with on collision enter. We first need to see and identify when a collision occurs. So the parameter to this method is a collision. We need to check what did we collide with. If we collided with the tile map, then we want to check the normal vector. If the normal vector for that collision is in the up direction, then we're going to set this ground field equal to the game object that we collided with. This has the potential to introduce a bug in that if it doesn't quite work when we collide, it will not stay. So we wrote this on collision stay method to ensure that this is true as long as we are attached to the game object and not just when we collide with the game object. We also check when we cease to be on the ground, we will set the ground object to null. And now we only want to allow the upward force if the ground is not null. So if we are on the ground, then the spacebar will apply much more force than we had in the last script. And if we are in the air, we cannot apply additional vertical force. Questions about this script before I showcase it in action? I will switch back if you have a question, which I will gladly answer. So let's actually see how this works. All right, I can still move left and right, but now when I jump, even even if I'm holding down the space bar and mashing it, it only works and only applies the force if I'm on the ground. It's exciting, and it allows us to do fun things like jump to the next platform. Exciting. However, we note that in order to move to what might be some additional platforms, we want the camera to follow the player and not to stay centered in the world. So to do this, by player, we are going to take the camera and make the camera a child object of our player object. And we can do this by dragging our camera onto our player, and this makes it a child of the player. Now, if we were to run the game again with everything the way that it has been set up, what we see is that, sure enough, the camera follows the player at all times. And sure enough, now it seems like we might have a bit more playable game as we discover these other platforms that we made prior to our presentation. All right, I will hand this back to Chad for the next section.
All right, so we're getting somewhere. But if we play the game again, we'll notice something that's not super fun, is that if I attempt to make some jumps here and I fail to do so, I fall to my death. But I don't really fall to my death. I just fall forever and ever and ever. It'd be much nicer if I actually did fall to my death so that I could restart the game without having to literally exit it and recreate it. In order to do this, we're going to have to do a bunch of steps. When the player has died, we want to notify them in some way that they have died and the game is going to be restarted. There are a couple of ways we can do that, but in order to notify them, we're just going to overlay some text on top of the window. To do that, we need a few more objects in our game. First, we're going to create, under the UI menu, a canvas. A canvas is a thing that we can put other UI objects onto. It automatically comes with another thing called an event system. We won't be using that at all, but if we were to put things like buttons or drop downs or other interactive things on our canvas, the event system would cause them to fire. The only thing that we want to put on our canvas is some text. You'll note that the text automatically became a child of the canvas because I created it not by right-clicking down here in an empty spot, but right-clicking on the thing that I wanted to become the parent. I'm going to rename this because we'll eventually have multiple text areas. And then I'm going to edit some of the properties of the components that a text automatically has. Quite a few of them, in fact. I recall during the discussion in the last one of these presentations on game jams, you were given a suggestion, which was build everything and have at least your minimal working product done very quickly, because it takes a long time to adjust parameters and tweak things, which is very much true. We're able to know this is exactly the size I want this to be because we spent a lot of time figuring that out. But if we were building this from scratch, we would need to spend quite a lot of time trying numbers, seeing that they didn't work, trying other numbers. So we're changing the text here to be "you died restarting." I changed the width and height to be large enough to hold that with the new font size that I'm going to set. And I'm going to change the color of this text from black to, since we are telling the user some unfortunate information, a bright red. The other thing I'm going to do, which is pretty weird, is I'm going to uncheck this box up here. And I'll show you why. If I play the game right now, it will tell me all the time that I died and that the game is restarting. But of course, I haven't died yet, and the game isn't restarting, so I shouldn't see that text. By unchecking this box, I'm saying this component exists, but it's not currently active. I'll have to do something later to enable it, and I'll be doing that in my script, turning it on and off at appropriate times. So let's go back to our player, remove the version of the script that we've been using, and find the new one that we'd like to add. In here, we'll find all of the code that we've seen before, plus some new things. We've added a new field that will allow us to refer to that text box that I just created. And in our start method, we go find that text box. So far, all the things we've interacted with would have been components of the same object, but now we're able to go grab some other object that's unrelated to the one this script is attached to. It's important, if possible, to do that in the start method, as we're doing here, because it's kind of expensive. We don't want to be doing it on every frame or every physics update. And then I've added a couple of new methods. The restart one first. The goal of this method is that it can be called whenever I have died to restart the game. So the first thing it does is change where the player is by affecting its transform's position. That determines the location of our object, and we want to reset it back to where it started at 0, 0. The second thing I do is change the velocity of the rigid body associated with our player, because if I've been falling to my death and gravity has been accelerating me faster and faster and faster and faster, when I restart the game, I don't want to have that super high velocity. I want to start at almost nothing. So I set my velocity back to 0 in the X direction, 0 in the Y direction. Then I call the built-in invoke method, which allows me to tell some other method to be run, not currently, but at some point in the future. So I'm telling it to call the unfreeze method, which is right up here. We'll talk about it in a second. After some small amount of time, 0.05 seconds. And then I'm changing the time scale of my game. What this is saying is that I want to slow things down so that what normally would have taken 1 second will now take 1/100th. Or sorry, I guess the other way around. What would have taken 1/100th of a second will now take an entire second. So time is passing 100 times slower than normal, which is why actually I set this to a very low number. The reason why I do that is so that when the game restarts, we will just sort of hover for a second or so, be able to read the message that we died and are restarting, and then the game will pick up. So this method that I'm calling in the future simply resets the time scale back to 1 so that we will no longer be going slow, we'll be back to normal. So I need some way to trigger this restart method to recognize that I'm falling to my death and I want to restart the game. We do that down in our fixed update method, where we're just going to look, what is my current Y position? My Y position started at 0. All of my platforms are higher than that. So if I were to fall to a Y position of, say, -15, I could be assured that there's no recovering from that. I'm just going to be falling forever and ever. So at this point, I will enable my restart text. Recall that we unchecked the box so that it was not enabled originally. And then I will restart the game by calling the method we were just looking at, which puts us back at our original position, original velocity, and slows things down so that I have a chance to read that restart message. I'd also like to have that restart message go away at some point. And there are a variety of ways I could have done that, but what we decided was to make it go away when we touch the ground. So back up here where we are discovering collisions, if I'm colliding with a platform and I'm colliding with the top of it, in addition to saying I'm grounded so I can jump, I'm also going to tell the restart text to turn itself off if it was on, so that our error message will go away. Or not error message, but our dying message. So let's see if this works. I'm on my platform. I make a couple jumps. And I jump too far, and I miss a platform, and I'm falling. And the game restarts. It tells me I died and that it's restarting. It restored me to my original position. And as I fall and the game actually gives me control again, the error message goes away. And now I can play the game again. Pretty cool? So we have the ability to die now. It would also be nice to be able to succeed in some meaningful way. I should have some goal and some way of recognizing that the player achieved the goal and rewarding them. So our goal for now is just going to be that we've reached the top platform. And in order to note that we've done that, we're going to put a new object on top of the very top platform that when we reach it, we'll be able to say we've won the game. So we're just going to make another sprite for that. we will pull that sprite into the world. And then we'll make some changes. It shouldn't be white. It should be some other color. If I recall, our player is green, so let's make this blue, perhaps. And I'm going to change the position to be a position that I previously determined. Should put it directly above the top platform, at least hopefully. If not, we can reposition it later. All right, so that object exists, but it's just going to sit there. It's not going to do anything. The first thing I'd like is to be able to know when I am touching it. That means I need a component. We're already familiar with this component. It's a box collider. However, we're going to use it in a different way from before. Our box collider that is on our sprite is a normal unconfigured one, which means that when we collide with something, the physics engine prevents us from moving through it. With this collider, we don't want that to happen. We should be able to move through the victory object. We just want to be able to be notified when that collision occurs. So I'm going to check a box here in the inspector called isTrigger to turn this into a trigger collider, so the physics will not apply to it. I'll simply be able to recognize, have I collided or not. I also want to have some way to notify the user that they have won and to restart the game. So just like we've got a restart text, I'm going to create a separate text that notifies our victory. Like the other one, we're going to change the text to a custom message. We're going to adjust the width and height and the font size and the color. We'll make it blue to match the victory object. And of course, we're going to need a script, which is going to allow us to notice that we have collided with the victory object and thus turn on the victory text, which should not be on automatically, and then restart the game just like it restarts the game when we die. So that means we need a new player script. So we will remove this one. And we will add the new one. And then we can go look at it and see what it does. So we've added another game object for the victory text. We, when the game starts, go find the victory text so that we'll be able to do stuff with it. We now have a new method here called onTriggerEnter. This is like onCollisionEnter, but it works for colliders that are triggers. So when I encounter a collider on some other object that is a trigger collider, this will be called. I want to check to see what I collided with. Hopefully it's the victory object. And if so, I can turn on the victory text component and I can restart the game. I'll also need to turn off the victory text component down here when I collide with the ground, the same way that I was doing with the restart text. And I am, when I collide, calling the same restart method that we were already using for restarting when we died. Regardless of the reason you're restarting, the process of restarting is the same. So we can see if this works, though it's going to require me to win my own game, which may be more of a challenge than you'd imagine. Climb up some platforms. Hopefully not fall to our death. There's our final platform, and we can see on top of it the thing that recognizes our victory, like a door that we're walking through that gets us to the next level, perhaps. I touched it. You can see you made it. Perhaps blue on a blue background was not the best choice. And then we've restarted the game, and we can play again or stop as we'd like. So we're getting to a complete game. We can move around, we can jump, we can die, we can succeed, but it's still a fairly boring game. So I'll let Chris talk briefly about how we might make it more interesting.
Yes. So to make this a little bit more interesting, we would like to possibly make some collectibles that we could collect on the way to the victory object. So we are going to showcase a little bit about how to do that. The first thing we want to do is to make the collectible object. So we're going to make a new sprite. In this case, that is a circle. It's going to represent a coin. We will call this a coin. But we're going to, rather than just make this an object, we want to make this what we call a prefab, meaning that it is about to be fab, but we need to modify it before it is fab. So the first thing we can do is we can drag this coin in its generic state onto the hierarchy, where we can now edit its properties. We want to change its color. Coins are usually somewhat yellow, so we will make this yellow. We want to change the name of the tag here. Rather than be untagged, we have pre-made this tag of a coin. So we're going to tag our coin object with this tag. This will be useful later when we collide with something. We want to know if that contains the tag coin, because we don't want there to just be one coin. We want there to be lots of coins. Before we do anything else, I want to quickly change the position of this coin so that it is a little bit out of the way. Actually, let's do that. Let's zoom out a little bit. Which is
Drag
not
down.
Yes. We'll zoom out so we can see a little bit more of the world. And let's start placing some coins. So before I do this, I have one more thing I want to do. I want to add a component to this. I want to make sure that there is a collider with this particular object. So I will make this a circle collider. We'll add this circle collider. We want to check the is trigger checkbox because this will be a trigger collider again. We want to see when we run into the object. We then, rather than just leave the coin in the hierarchy, if we drag this back into our project, it becomes the copy of all of the changes that we made, such that we don't have to make lots of copies of this original coin and change all of those in each one of those. Now we have this new coin object that we can drag multiple times onto the hierarchy and make multiple coins. For each of these coins, we can select them, we can drag them around, and we can place them in different places such that we can collect them. If I can actually select, I think I zoomed out just a little bit too far and put this right on the other line. But now we could select, create, and drag. But I think we are just about out of time.
Perhaps we can switch scripts and just play the game to observe what happens without looking at the script.
Yeah, we are running up to the end of the session, gentlemen. But yeah, definitely playing through would be fantastic, and we may have a minute or two for open questions as well.
Sure. While he's doing that, I'm sure you could imagine what that script does. Much like when we collide with the victory object, we can check for collisions with coins using on trigger enter. And then we want to make those coins disappear. So we disable several of their components so we can't see them and we can't collide with them anymore. We haven't implemented this yet in this step and won't have time for future steps. You can also increment a score counter when you do so. And then whenever we restart, we have to go find all the coins and enable the things that let them be seen and collided with so that the game can restart and the coins will be there again.
Kevin had a question. Is there a Git repository of the game, maybe with commits in the same order as the presentation by any chance?
There certainly can be. There's not at the moment.
Okay, great. Thank you.
I assume there will be some way that we can make a URL of that available after the conference is over.
Yes, absolutely. We will, the CPOS team will be making links available as well. So if you have something, you can just share it out with us.
All right, great. So thanks very much for your time and attention. You can probably imagine many other things you could add to this: the ability to keep score and display that score on the screen, the ability to create enemies that walk around, and when you collide with them, it depends whether you're jumping on them or them jumping onto you as to who dies, and various other things. All of which can be accomplished by using these built-in components, sprite renderers for graphics, colliders for noticing when you run into things, rigid bodies for movement and physics, and scripts on your own. Anybody have any questions we can answer other than Kevin's?
All right, great. Chad, Chris, seriously good work. I was wondering how far you would get in, roughly 45 minutes, but, as an introduction, you got very, very far. So terrific work on this. We all thank you very much for, your time and your work to build this talk for us this afternoon. Really, really great work. So thank you again for presenting Unity for all of us this afternoon.
Thank you.
Yeah, thank you for moderating, and thank you to everybody who joined us for this talk.